Just a quick heads up, you can see my full screen and you can hear me.
Yes, I can hear you.
Okay, thank you. Okay, so as mentioned, today's presentation is going to be on the Daikin Applied or chiller portfolio for the year 2021. And Daikin is the highest peak in chiller technology with the latest developments in our chiller ranges, which you will see later on through the training with our refrigerant selections as well as our electronics and compressor designs. So why would you want to choose a Daikin chiller? Daikin chillers are a perfect bridge between project requirements and customer satisfaction. From the smallest chillers to the very largest, our quality control and attention to detail is absolute. Our systems have the most advanced technologies and deliver the highest efficiencies as well as lowest running costs, and are the gold standard for reliability and performance. So Daikin definitely offer the widest and most flexible chiller portfolio, worldwide experience in chiller design and manufacturing, and the highest efficiencies for every installation as well as quality and reliability. So this is our air-cooled range we're going to look at. We break this up into two segments. We have our scroll range, scroll compressors, as well as screw compressors. We go up to from virtually 5 kilowatts up to 675 bordering 700 kilowatts in scroll capacity. We offer inverter compressors as well as the standard compressor operation in scroll. And we also offer the screw designs, which pretty much start from 100 kilowatts, and we got right up to 2.1 megawatts in air-cooled. And in the inverter range, we go up to 1.8 megawatts, starting at 170 kilowatts. So this is pretty much what we offer in our air-cooled ranges, up to 2.1 megawatts. We start right down with the small chillers, which are predominantly low capacity. You can use these for little wine chiller, cooling wine storage for residential properties. These come in single phase. This is all our inverter range that we offer. And then we offer right down in the scroll, the non-inverter with R32 refrigerants. This is our newest lineup chiller, which has been released this year, which we'll get onto now. It's the Focus. It's a new small inverter chiller, which is pretty much a derivative of the initial VRV design. So if we look at the mini chiller range, which comes in single phase, it's pretty much a plug and play application, a contained package units from 4 to 8 kilowatts. If you have a slightly bigger load, we have the dual fan. These do not go down to brine versions, unfortunately. So the coldest you can get is about 6 degrees on these chillers. 5 if you're pushing it, but we don't go lower than 5 because we do not have the brine version. This is our new 2021 range that's come through. At a glance, it comes in cooling only as well as heat pump. We've increased the range from 63 kilowatts up to a 90 kilowatt range. These all run on DC inverter scrolls. So this is digitally commutated through our inverter technology. We have the standard as well as boost configurations. So what the boost pretty much means is we can overgenerate voltage on the inverter board to run the compressors up to around 130% for quick pull down times. Copper and aluminium coils, braze plate heat exchangers, high efficiency digitally commutated brushless axial fans. So these are pretty much hub motors. And we also have an inverter pump kit, which offers a low and a high lift pump, depending on the head you need to overcome. So even the pumps for energy saving are fully inverter driven. Capacity range is 16 kilowatts, right the way up to around the 90 kilowatts, 88.3 at these test conditions. The range overview in the cooling only, we can go down to minus 13 degrees for brine and process applications, right the way through to comfort cooling. Well, this you can pretty much also do a bit of ice storage or ice harvesting with these chillers. Comfort cooling, process cooling, as well as data centers. We can handle chilled water up to 20 degrees. We can also perform these conditions in extremely cold weather, as well as extremely hot weather. So this would not really apply to South African market, 52 degrees. So these chillers will still be able to condense at 46 degree ambient, which is very unlikely that you're going to get those high temperatures. But in extreme situations, we can put a high ambient kit on, which will be you'll still be able to condense at 52 degrees. And here as well, you will still, for process cooling, you will still, even if the outside temperature, say, drops to minus 10, you will still be able to condense and provide your cooling for your data centers or whatever your process may be. And this is pretty much what the parameters that these chillers fall into. Everything thermodynamically is balanced, so we do work within confines of the thermodynamic laws and principles. So we can't take sometimes extreme water, extreme high return water with a very high outdoor temperature, is in you wanting minus temperatures. We work within an envelope, which is what is thermodynamically possible. But we were able to calculate any of that for you on our software. But here, typically, you can see chilled water temperatures for ideal situations. Pretty much comfort cooling, we leave in about the 4 to about 13 degree range, supply and return water temperature, and up to 25 degree return water for data centers. We don't want to supply too cold water to data centers because you're going to get too much condensation on the lines, and you don't want to dehumidify the air too much in a data center. So we don't make the chilled water too cold, else you're going to create high static electricity, which we want to avoid. We also provide the heat pump version, so we can generate hot water for you as a byproduct of the cooling operation. The coldest water we can generate for you is 20 right up to 60 degrees, which is really hot. That's sort of your geyser temperature. Most geysers are set at around 55. However, we can generate up to 60 degrees water for you. And here we will still be able to condense and provide this service up to 35 degree outdoor temperature and down to minus 20 outdoors. And this is pretty much hot water production is pretty much guaranteed all year round within these outdoor air temperature operating envelopes. So you will, if you want to use this as a heat pump for hot water generation, and being an inverter, it's very efficient on your coefficient of performance. Now we go on to the Blue Evolution chiller series, which is R30, works on R32 refrigerant. These generate, we operate from 80 kilowatts up to 700 kilowatts. Scroll compressors, we work on microchannel condensers now. Microchannel coils, which are fully aluminium. There's no copper aluminium. Braze plate, axial fans. We offer silver and gold efficiencies. What these pretty much mean is the physical footprint of the chiller. If you go for a gold, it's a slightly bigger chiller because we allow for extra surface area for you to condense. 3 different sound configurations, and we've got extensive option lists available on these chillers, from power factor correction to pumps, you name it. There's extensive range available. So the microchannel coils and R32 refrigerant, why we use them is to reduce the environmental impact. So if we look at the combination of using a microchannel coil, as long as our new R32 refrigerant brings to around 68% reduction in refrigerant charge versus a previous R410 chiller. So we're using up to 68% less refrigerant by changing the coil material as well as changing the refrigerant. So for environmental purposes, it's a huge advantage using R32 refrigerants in combination with aluminium coils. So how do we understand this in layman's terms? So if we quantify this, the reduction is quantifiable in the lifetime of carbon dioxide emissions of equivalent 4 passenger cars. So how do they calculate this? So if we use a 540 kilowatt chiller with the same refrigerant charge compared to using an R32A chiller, and if you look at what a car puts out in grams per kilometer that you drive, and they've taken it over 240,000 kilometers. They estimate that's how long in Europe conditions that your car should last. You're reducing what these 4 cars would put out just by selecting a R32 refrigerant chiller with the microchannel coils. So environmentally, it's a huge benefit. Now there are different models. This is what we call the single V block. The condenser is in the shape of a V. It was developed starting from the current R410 range that we have phased out, and we've put new R32 refrigerant in, and we've optimized the compressors as well as the heat exchangers. So we go single circuits as well as offering dual circuits. Then we also offer what we call a modular V. So we've pretty much taken this V block and turned it sideways. And we offer this as well in single circuits up to 350 kilowatts and in dual up to 701 kilowatts. So what are the benefits? There's over 70 different options you can choose from when selecting this chiller. From hydronic kits, which will be expansion tanks, hydrospheres, pumps, dual pumps, high lift pumps, low lift pumps. We also offer heat recovery on these chillers, where you have you supply your cold water, we take the heat of rejection out of the evaporator, and we put it into the return to your water storage. We also modulate the compressor load with a special refrigerant migration technology, which is patented to Daikin, which I'll go over a bit later in the training on how that actually works. Very importantly, a lot of sites are very pedantic about sound. So in the V block range, we offer a standard option sound. We offer then low sound as well as reduced sound. Minus 1.5 dBs. These are normally taken at a 1 meter distance from the chiller. So what do? We insulate the compressor cabinet. So if you open this cabinet, there's foam padding being put in here. And to drop it even more, we insulate the cabinet and we reduce the fan speed for head pressure control. In these models, we have obviously the naked compressors, so they're not covered in insulation blankets. They're just exposed to atmosphere. But here we put the compressors in cabinets and we insulate the cabinets. And to get an extra reduction down on these to minus 8.5 decibels, we do all of the above and we put variable frequency drive fans in. This also offers you a much more linear and better head pressure control on your condensing pressure, having the VFD fans. So besides being quieter, gives you a far more linear head pressure control, which means better energy efficiency. This is the heat recovery option available on these chillers, where we produce cooling and take cold water and we produce hot water. So we can recover up to 85% of the unit's heat rejection with heat recovery. So instead of this fan spinning and us wasting the recovered or the rejected heat, we put that heat, comes straight out of the compressor and goes into a desuperheater, which we call a heat recovery exchanger. And we desuperheat it, but we don't subcool it. We just desuperheat the gas. So by the time it leaves this desuperheater, it's still in vapor form. And the condenser fans don't have to spin that much. So besides you getting hot water and inverted commas for free, your condenser fan is going to be huge energy saving because it's not going to be spinning that much. And in this specific chiller, with this double V-block assembly, you can easily get up to 55-degree water for showering. And it's ideal, for example, for hotels, storage water. Then these are the hydronic kits we offer here. You can see how we would put the storage vessel. This is pretty much what we call a buffer tank. The pump, single pump, dual pump. The chiller will come configured with a duty standby configuration to balance the run hours. This is pretty much, there's 8 different combinations available. Plug and play, all the electronics are done for you. Just connect the water pipes. Like I said, expansion tank along with the buffer tank. Depending on the chiller size though, as a rule of thumb, normally 5 to 8 liters of water is needed. Sorry, 5 to 8 liters of water minimum per 1 kilowatt of cooling. So if you don't have enough water pipe or water reticulation in your system, you can have one of these buffer tanks put in to absorb the buffer. If not, you can put an external storage tank. We offer up to 1,000-liter external storage tanks, which come insulated as well. The variable primary flow design that this chiller also has built in. So it's energy saving because we have inverter driven pumps as well as variable flow control. So your furthest unit would have a pressure sensor across it, and this pressure sensor, as the pressure drops across the chiller, it would send a voltage back to your PC board to tell this pump to slow down or speed up. So there's continued energy saving depending on how you parallel your loads within your primary loop circuit. Also on this system and controls, we offer BMS communication for Modbus, backnets over IP or LONWorks. Further options that we offer is Daikin and Chiller Manager or the Intelligent Manager. We're also promoting as an option Daikin on Site, which is a virtual cloud accessible platform where there's dashboards where an operator, you can have different modes where a technician can go on and look at different faults. Your operator can go on. It's all accessible on a tablet with Daikin on Site. And a lot of these things come free, hardwired, I should say. What's hardwired on the chiller is a 4 to 20 milliamp set point, demand limit, current limits, network local switch, which didn't used to come free in the past. This now becomes part of the package with this model chiller. We're also able to offer you master slave configurations, up to 4 units without an external control. All the integrity is built in and the knowledge base is built in on your master chiller. We just daisy chain the chillers, and the chillers will then balance the running hours of the units to enhance system reliability. And we also have pump control, all from the chillers without needing third-party devices, all built in. We also have the Intelligent Chiller Manager, which is a far more advanced system, which are further options which can be inquired upon depending on what the consultant would like or depending on what the plant requires. But we do the basic, the light, and the full control, which is up to 8 chillers, 8 pumps, variable flows, primary, secondary loops, variable constant flow. So it's a very complex design, but we can offer this as a turnkey solution to control everything within your plant with up to 8 chillers. So to conclude with this, it offers low running costs, fully customizable. It's got advanced connectivity for third-party controllers. It's quiet in operation. The main unique feature is the R32 refrigerant, and with this it comes with very good seasonal efficiencies. Now we're going to go on to our screw compressor range. Remember, we've just concluded the scroll compressors. We're now going on to our screw compressor, our larger capacity ranges. And I will go through these different chiller options with you, but interesting to note the different refrigerants we have. We have R1234ZE, along with R134A. I'll explain what the R1234ZE is a bit later on in the training. So this is pretty much our entry level in screw compressors. It's condensing units with fixed speed compressor. So this is non-inverter. Available in 2 sounds and suitable for sort of any kind of remote evaporator. So this does not come with an evaporator, this chiller. This is purely a condensing unit. So it will have a compressor, your condensing fins, or your condenser, I should say, and your fans to help the condensation. You can buy a third party or a remote evaporator and plug it in, say 10 meters downstream. And this will be able to plug in hydraulically. Sorry, refrigerant wise, you can pipe this all the way through to your evaporator. So that's a remote condensing unit that we offer up to 448 kilowatts. Then still in our non-inverter range, a cooling only chiller in 134A. These chillers get really big, up to 2.1 megawatts. Also come with a standard noise, low noise, and reduced noise. Single screws, we use microchannel condensers, axial fans, and direct expansion, shell and tube. So we've migrated, we're no longer on braze plate, we're on shell and tube for these specific units. We also do, I've included this in the training, a chiller that is specific for process cooling only, also up to 2.1 megawatts. It's got a slightly different algorithm in the software. And importantly, process cooling applications, you'll notice that most chillers work in EER, energy efficiency ratio, or SEER, which is seasonal energy efficiency ratio. But because we're cooling down a process where throughout the year, the cooling load will say be the same, be it a bakery, be it an injection molding plant where you're melting plastic, regardless of the outside temperature, you're cooling a set design load. So this is the kind of chiller that you would select. Its energy performance is work calculated differently, and we calculated on average a full year operation of 8,700 hours, and we're going to assume 100% cooling demand. So this thing's virtually going to run at 100%, and it takes into calculation if you run down to 80%. So if this is a process cooling application, this is the chiller to use. It comes with a C for the process cooling application. So in the B range, this also comes down in a brown version, partial and total heat recovery, master slave, rapid restarts. So very versatile chillers in the 134A range with a lot of optional extras. These are only just some of them, of the options that we offer. Interestingly, on these chillers, when we do the low sound for you, this is pretty much what we do. So because these are screw compressors, we put the condenser fan, when it rotates at around 9, we limit it to the RPM to about 900, and we put rubber vibration mounts under the compressors. When we go even quieter, we almost put like an expansion bellows in the refrigerant pipework to stop resonance of the pipe and pulsations through the pipework. And we put this on the suction line. Being 134A, the suction pressure is probably going to be about 2 bar. So it's no real danger of this thing rupturing. And then very, very reduced sound. We drop the the condenser fans down to 700 RPM. Rubber mountings on the compressors. We seal the compressors in a box, as well as this coupling on the suction line. So we're going to focus, Daikin's core focus is inverter technology and energy savings. So we're going to look at now the EWA, the TZ range, which is the core focus of our business. We're also going to look at the 134A, as well as the cooling only 1234ZE range. So what are the benefits of using inverter technology on our screw compressors? Well, if we look at a conventional chiller, a double screw, you will see that at 100% capacity, and 50% capacity and 25% capacity, there's no variation. All you're doing is altering the geometry of the combustion area, not the combustion, but the compression area. However, the compressor motor, the rotor is still spinning at maximum RPM. We're not modulating the speed that the rotor is spinning at. So these things spin at a set speed. We just alter the compression cycle using a mechanical slide control. Now, if we look at Daikin's unloading technology, when we need to unload as the load drops, we have a single screw. Notice these are twin screws, which we don't use, and Daikin don't use twin screw technology. They're very noisy, high maintenance because of all the wear metals, up to 6 times more bearings in them compared to our technology. So we use a single screw, and as we unload the technology, we slow the compressor down. And here you can see at 50% speed, we drop the RPM right down. And we have around 25% speed. We have to spin at a minimum rate, so we don't have mechanical stall. And our inverter still generates a bit of back EMFs on the electrical motor. So we still have to maintain a minimum anti-stall speed within our system. So what are the benefits of the inverter? Well, we have the best efficiency in the market. So if we look at this chiller's power inputs, a screw compressor with mechanical unloading, using up to 73% power. But the screw compressor, which is inverter driven, if we look at this linear line on the graph, power consumption is significantly reduced at part load, where the machine will run for at least 97% of its operating hours. So what does that mean? Unless, I said to you earlier on, unless you're using a process cooling chiller, and then you would normally size that for 30% more. So if your load is maximum 100 kilowatts on the process, you would select 130 kilowatt chiller. So it tries to run on its sweet spot. However, with inverter chillers, when you're doing comfort cooling, they will modulate all the time. And most times, if you're not doing process, if you're doing purely comfort cooling, 90% of the time, 97% of the operating hours, it's going to run at part load conditions, which is huge energy saving. It's 32%, give or take, less energy consumption than a mechanical screw which is fully unloaded. So what are the other benefits of inverted technology? Well, first of all, this is what the Daikin technology looks like. We have a single screw with 2 gate rotors. They are 180 degrees out of phase, mechanically out of phase with each other. These are purely to balance radial and axial forces. But besides that, with us using our inverted technology, there's no reduced mechanical stress. So as well as electromechanically, there's not much stress. So the bearings, there's not a lot of wear metals because you're not suddenly starting this from rest to 3000 RPM. You're gradually winding it up. So your oil doesn't get as dirty as quickly because there's less wear metals. We have a very high power factor, which may be a bit of a foreign sounding word to some of you. But pretty much what power factor does is we need to generate extra power to energize electromagnetic fields within the stator. But because we have permanent magnets in our rotor configuration, we don't need that reactive power. So we free up the transformer. So let's say you've got a factory, each time you start the chiller, a normal chiller will take huge power from the transformer to create a magnetic field to get the chiller rotating, the compressor rotating. We don't need that. So our power factor runs just below 1 at around about 0.97. There's also no inrush current, which is fantastic for transformers as well as switch gears. When you have inrush current, a switch gear takes a lot of thermal load on it, and your breakers and your contactors don't last with huge inrush currents. And even your cables heat up terribly. We don't have inrush current. It's just a linear current draw, which is the bottom. There's no power spikes. So if you look at this chiller for likeness, if we had 3, say 100 kilowatt chillers, if I selected a soft starter on this chiller, which would be pretty much a part wound start and run motor, you can pull up to 300 amps. If you have a star delta starter, you're going to pull around 200 amps, then drop as you go into delta range. And then you're going to peak as your inrush current, as your magnetizing current would possibly pull in. You could get any kinds of spikes. However, on an inverter, it's linear. We probably start at 20 amps and we go right up to the running current. You'll notice all of these are also as back EMFs kick in, the running current drops right down to your running amps. We also have low noise levels at part loads because we commutate the rotational speed of the compressor. So when we get, say, to 20 degrees, we can commutate the whole system down to 25% or 50% load. And all that adds to much quieter operation, slowing the RPM down of the compressor as well as modulating the fan speeds. So I mentioned earlier on to you about the Daikin inverter screw technology. So what we do is we combine inverter electronics along with this mechanical technology, and this is Daikin's unique single screw design for perfectly balanced loads, which we combine, as I mentioned, with inverter technology. So this is obviously all slid into the housing. Your motor would be here, your compression cycles, your discharge zone with your oil separator. This isn't metal. Well, that's metal to support the housing, but this is a composite material called Riton, and we use that to absorb to provide our compression geometry to give us ultimate compression when we go in these grooves. And hopefully there's a symbol of it here. But anyway, let me show you why I said we oppose these geometries is because besides balancing radial and axial forces, it also allows us maximum compression. So we use virtually 360 degrees of the rotor for compression. So we compress on the top with this gate and we compress on the lower half of the rotor with this gate rotor. So upper compression as well as lower compression, and we discharge radially through both these volutes. Also, as I said to you, these gate rotors oppose radial thrust. So radial thrust is thrust that throws out at 90 degrees to your angle of rotation. And axial thrust is something that is thrust in the line of rotation. So both radial and axial thrusts are naturally balanced with our Daikin screw compressor. And we only have 6 bearings in this. If you had to compare the opposition, some of them have up to 30 bearings in their compressors to balance loads and to also, well, it's primarily to balance radial forces, which means a lot of noise in those bearings go and a lot of wear metals in the oil. Further to that, Daikin has also introduced what we call variable volume ratio to improve on our energy efficiency. So this is a bit of a complicated design, but it works on a volume ratio. It works on volume, and a ratio is a difference between two things, like 5 tablespoons of sugar and 2 tablespoons of salt. That's sort of a ratio that you would put in if you wanted to, say, cook something. We work on a very similar principle where we work with volume on the suction divided by volume on the discharge. And combining all these 3 technologies makes us very, very energy efficient in the market. The inverter, our mechanical uniqueness, as well as using our volume ratio of a suction and discharge. Only guys in the industry that offer this technology. So let's look a bit more at the compressor. What is unique about this? Well, first of all, the electronics is built on top of the compressor body. What's the advantage of this? Well, refrigerant cooled inverter. So we take subcooled liquid from the condenser. We don't physically use evaporated temperatures because that would create sweating and it would blow the electronics. But these electronics run at about 85 to 90 degrees. Subcooled liquid from your condenser is probably around 45 degrees. So there's still a 40 to 50 degree difference, and we pop subcooled liquid on the back of these heat sinks, and the liquid then boils off, returns to a little subcooler, back to the condense line and subcools even further before going to the expansion valve. So the good thing with these electronics too, they're also in an electrical box, so no dust from plant rooms, factory dust gets in. It's all sealed and it's all cooled with liquid refrigerant. So even in the event of load shedding and this chiller suddenly stops, conventional electronics would rely on a little cooling fan within the cabinet. That would stop, so these electronics would overheat, and the heat conducting paste on the back would harden with time, and you would blow your IGBT module and you blow this whole inverter board. The good thing with liquid cooled electronics, even in the event of load shedding, because of pressure differentials within the system, the heat from here will still draw because of the pressure difference, and the cooling cycle is still going to take place as it draws subcooled liquid out of the condenser. So it's going to continually cool without any active power. Another advantage with Daikin using this inverter technology is a digitally commutated motor. Don't go think you can put your fluke meter on DC and expect to get any readings. You won't. A digitally commutated is pretty much still an alternating current motor, but we take power and we pretty much chop it up with a set of switches, and we create superficial alternating currents, or quasi. But that's another course to offer, and if you want to know more about that, we've got how power inverters work on our Daikin YouTube channel. You can go and watch that training that I've done there. And another unique design there, once again, is the variable volume ratio, which will optimize compression, internal compression. Remember, the higher the compression ratios, the more electricity I have to use. So if we don't need to over compress, we don't have to. We're continually modulating the internal pressure of the compressor. Let's have a quick look now at micro channels that we use. These offer very high performance because of the good delta T across aluminium. It's reduced weight. Because it has a great coefficient of heat transfer, we don't need as much refrigerant. Structurally, it is very strong. It's supported in these header tubes, I should say. And anti-corrosion options are available. However, importantly, I've included in the slide, you'll notice there's copper joining aluminium here. In the real world, you can't do that. You can, but it's not going to last very long, because in the event of this getting wet, this whole coil becomes a battery. And when it becomes a battery, this coil will generate probably 4.5 to 5 volts when it gets water on it. And as such, the aluminium coil will start forming a powder, and it will become what you call a self-sacrificial anode. We don't want that to happen. So what we do is we galvanically isolate the copper from the aluminium with these protective sleeves. Because initially, this is going to be where the leaks are going to happen on this connection. Where the copper touches the aluminium under these gray bits, it's going to form a battery. So we've already got protective sleeves in place to prevent the galvanic corrosion taking place. Now we're getting onto the bigger chillers, the bigger capacity ranges, also an inverter. We offer this in R1234ZE refrigerant as well as R134A. Important to note, though, that depending if this is sort of a green building design, HFO 1234ZE, when it comes to a global warming potential, it's lower than carbon. Carbon is 1. This is about 0.7 something. It's much lower than carbon. Whereas 134A, you're looking at probably about 1200 global warming potential. But there's still a lot more energy in R134A. When I say energy, heat transfer capability, so we can cool up to 2 megawatts if you select 134A. We derate the chillers if we're using the more ecologically friendly refrigerant, because it's less environmentally damaging, but it doesn't have the best thermodynamic capabilities like the R134A. So if we look at these inverter chillers, we'll see that at part load efficiencies, at the gold, This is silver, gold, and platinum. If we use gold, for example, at part load, seasonal energy efficiency, we're running over 5, which is very, very good. And at full load, we're going to run at about 3.2. You never ever select I mentioned earlier on, if you've got a process cooling, even with inverter chillers, it's a fine line on the initial design, because inverters use they use more electricity at full load than a non-inverter chiller, for the simple reason there's a lot of heat generated in the power electronics, as well as the heat of compression. You add those two together, the energy efficiency ratio drops at full load. This only happens at full load. So at full load, an inverter chiller is less efficient. So it's not advisable to select an inverter chiller for a full load operation. You give yourself 30%. You size the chiller 30% over capacity, because as we said earlier, 97% of the time the chiller is going to run in the sweet spot when the compressor's unloaded, and that's where it's going to surpass any other non-inverter chiller. The silver, gold, and platinum option is merely the size of the chiller. So if I wanted to go platinum to give myself seasonal energy efficiency of about 5.8, I'd possibly have half a V block installed further to just give me that extra heat rejection. So on our inverter chillers, if we look at these quadrants, ambient temperatures, we can still condense at 52-degree outdoor temperature. Evaporating water, we can go up to 18 degrees supply for data centers. As I said, you don't want to go too cold in a data center. You're going to have too much dehumidification. And here's the sweet spot for comfort cooling. We can go down to minus 18 degrees outdoor temperature. We can still provide cooling for you. And on these specific chillers, being inverter, we can go down to minus 8 degree with brine or glycol mixture. Some of our chillers, depending, like scroll compressors, they generally can go down to about minus 15. So you can't go that cold with screw compressors. It's just the thermodynamics and the design process. It is give and take. There's a lot better control on a screw compressor for loading and unloading. With scroll compressors, it's either on and off, unless you go for the fully inverter. But these are designed screw compressors are not really designed to switch off. They're designed to run in the morning to sort of night and modulate by unloading their compression cycles. They don't like to really run on and off. And to date, we have well over 700. This is probably bordering about 1,000 now of these units installed around the world, with over 300,000 kilowatts, which is a lot of cooling capacity installed around the world already. Further extended features that you can get on our inverter range is multiple units sequencing capability. So if you look at multiple chillers on a normal plant with a standard application, when your load drops to say 45%, these chillers will switch off this. You're still going to have one chiller running at 100% and this jockey chiller assisting it. However, if you go for the Daikin chiller with the master slave configuration, when the load drops to 45%, we run all 3 chillers at 45% load, just to balance the run hours. And it's also going to be more energy efficient than running this chiller at 100% load. And here you can see by this configuration, you can save up to 10% operating cost. And considering what these chillers consume in kilowatts per hour, it's phenomenal saving over the year. 10% is phenomenal. We also offer, as I mentioned earlier on, the variable speed control on the chilled water pumps for variable primary flow. The important thing is on your furthest load, you have to have a pressure differential switch, which tells these pumps how fast to spin and how fast you run the motor to pump. And important, you need this bypass line for surplus and deficit flow. So So what is the advantage of variable primary flow systems? Well, up to 20% saving on these with the overall running costs, because most, besides your chiller running, which cycles on and off, your pump never switches off. So your pumps actually are responsible for a lot of energy consumption on the site. People think it's the chiller. Believe me, your pump is your silent killer on your energy bill. So if we commutate and we alter the speed of the pumps, it's going to be a big energy saving for you, which is ultimately a reduced cost for your water reticulation and reduced installation space by reducing piping designs and configurations. Excuse me. These are the platinum versions with efficiencies. Mentioning to you earlier on, energy efficiencies, don't look at them on inverters. They're very poor running at full load, but 3% of their lifetime they're going to run at full load. 97% of the time they're going to be running here, which is very, very good energy efficiency considering the size of these machines. Mentioned to you as well, I explained to you about the sound configurations. We can drop down to minus 10 decibels on these inverters. Standard sound is around 98 dBs running at full load. And if we look at 90%, 97% of running hours at part load, you see generally if a typical screw market, we've evaluated the whole market at full load, you're running at about, at about part load, running 97% of the time. All the oppositions chillers use are on average 4.5 SERs in screws in high efficiency and their standard chillers. So we're up to 20% energy saving on our platinum range, which is huge on energy bills. So ultimately, the inverter chiller is proven design upgraded with Daikin's latest technology, top class efficiency at part load, extended control features, and wide operating ranges, be it ambient temperatures, be it water temperatures. Another unique product that we offer is the 4-pipe chiller, air to water. It's a multi-purpose chiller. So if you wanted to say provide heating for geysers or boilers for a hospital, hot water for the kitchen, your laundries, you would typically have a boiler running, supplying hot water, and your chiller providing cooling. So Daikin have the solution now where this chiller can make hot water as well as cold water, as well as doing it at both the same time. So most chillers can either work as a heat pump, they can either only work as cooling only. This chiller can do cooling and heating at the same time. This is pretty much what the unit looks like. It works on 134A refrigerant. We start from 400 kilowatts up to 800 kilowatts, fully inverter, as well as the variable volume ratio technology, connectable to Daikin on site, and it comes with 2 sound options. These are important if you select these kind of chillers, say for hospitals. Sound is a big, or noise is a big factor for hospitals, for patient recoveries. So how does it work? So we have 2 separate circuits which can run independently. So here you notice this is the one set of heat rejecting coils, which is air cooled, and here we have our 2 shell and tube heat exchangers. So if we want the unit can operate in 5 different modes. So let's say we want cooling only, it's going to work like a normal chiller. Hot water rejected, warm water in, cold water out. Or we can use it only as a heat pump. We switch off the cooling, it's still going to run. Your condenser is going to become your evaporator, and we're going to generate hot water to the building. Here we can have cooling, equal cooling and equal heating operation. Here, if the cooling is less than the heating, so therefore now the chiller says, what do I do? What is this coil? Does it become an evaporator? Does it become a condenser? It makes judgment. So it can also still provide you hot and cold water regardless of the ambient temperature. Or if your cooling demand now is more than your heating demand, and say I'm going to use the word hospital, then we're going to switch functionality on these units. Notice though that these these shell and tube heat exchangers are still dedicated. Heating will always be on this side, cooling on this side. These are never going to change around. But the technology is going to allow your coils outside to either become an evaporator or to a condenser. So these are the 5 different options that this chiller can run in. So we are now going to go on to Daikin's water-cooled chillers. We've finished looking at the air-cooled ranges. We are now going to look at the water-cooled, but the scroll capacities up to 700 kilowatts, and as well as the chilled water screws. We do them in non-inverter up to 2.1 megawatts, inverter up to 2.1 megawatts. And then we do the centrifugal range. I'm not going to focus really on the centrifugal range, but we can go up to 21 megawatts. We have made chillers that big. It's a very, very specialized market, very special ordered chiller, but we can go up to 21 megawatts. So these are little hydrocube units with scroll compressors and water-cooled chillers with remote condensers, ideal for little indoor applications. We have multiple scroll compressors which you can sort of stack on top of each other. So this would be your single units, and then we have a dual circuit to parallel the capacity. Also indoor installation, all our units come with electronic expansion valves, and here you can see the braze plate heat exchangers. This is all designed to be very compact and fit in small areas. And we can go up to close on a megawatt in heating operation and just over 700 kilowatts in cooling. We can give you leaving water temperature of up to 55 degrees, and we can take evaporated leaving waters, we can give you down to minus 11 degrees. We also offer these chillers with multiple communication modules, the BACnet, LON, as well as Modbus. The good thing with stacking, by putting these units on top of each other, real estate costs a lot of money. So we pack these, we parallel the water flows on top of each other to reduce plant room space. We also offer a lot of options on these. These are very bulletproof chillers and very handy for what you get. Now we're going to look at the core focus once again. Daikin's core focus is inverter. And here we see the VZ series chillers. So these are fully inverter, water-cooled chillers. 450 up to 2.1 megawatts. We use, once again, Daikin single screw compressors. Actually, all our screws use single screws. We don't have twin or triple screws. Also, if we do, they're very, very noisy. We offer high efficiency flooded heat exchangers, and we have a new condenser design with a built-in oil separator, which I'll show you. We go up to 1.1 megawatts in the single compressor unit, and then we offer a dual circuit double compressor up to 2.1 megawatts. So everything is doubled on this chiller. We offer top class efficiency, compactness, application flexibility, as well as quietness. This chiller is also very efficient, up to 5.7 at full load on energy efficiency, and seasonal energy efficiency up to 8.3. You'll notice that water-cooled chillers are always more efficient. I'm talking chiller only. This is why these values are so much higher than air-cooled, for the simple reason we don't have fans spinning here, so we use less electricity. This excludes the cost of the pump running, which you'd need a pump going to your cooling tower fan. Those would reduce your plant room operating cost. But as for the chiller itself, Daikin will only supply you the chiller. The third party would be the pumps and the cooling tower fans, etc. But from an efficiency point of view, we are very, very efficient in the market, up to 8.3 on seasonal energy efficiency, which is very, very good performance. The condenser as well as the evaporator or flooded type technology, and we use rifling on the tubes. The reason we use rifling is we create hills and valleys, these little corrugations in the pipework, and what they allow for is a better heat transfer. We're increasing the surface area for heat transfer without having to make the condensers longer. So we remain the same, we maintain the, sorry, just give me a second. I just had something come on my screen there. So yeah, but by having rifling, we increase the surface area without having to make the chiller bigger. An important feature in the condenser is a single pass, parallel single pass, which is a real counterflow design, and the tubes obviously optimized for heat transfer and heat exchange. Our suction and discharge lines are specifically designed to minimize refrigeration pressure drops. So what does that mean? Even in the short bit of pipe work, by even reducing that pressure, by having an impedance of pressure, so pressure drops reduced by half, meaning that we have a 1 degree lower condensing temperature, which means we actually, by lowering the condensing or the subcooling, the condensing temperature by 1 degree, we increase the efficiency by 3.5% just by tweaking that discharge pipe out of the condenser. And once again, I can always do comparisons with other manufacturers in the market. Once again, looking at 97% of running hours, and on a seasonal energy efficiency, Daikin come out tops with up to 15% better performance on the Platinum range. This is a very unique feature of the single circuit chiller. This is ideal for retrofitting existing plant rooms. This will actually slide through a normal door. Even a door in your house, this chiller, as big as it is, we take off these 4 bolts that hold this electricity box on and a plugged wire. You remove this pigtail, the box comes off, you put this on a dolly, and you slide this right through a door. Importantly though, you have to let up to 900 kilowatts, you have to let the salesperson know, because the factory put a specialized bracket in here for you and a plug, so you can disable this fuse, this electrical housing. But you see the whole chiller is only 865 wide, so it'll slide right through a normal door. Ideal for retrofitting. So how is it possible to achieve such compact footprints? Here we see, mentioned earlier on, a traditional 2-pass condenser. The hot gas would come in from out of the compressor, and it would fragment at multiple angles. With a single pass condenser, we don't just chuck hot gas in, we put the gas in and we let it flow, contraflow. So you'll see there's a lot more time in contact with the water. Okay, so there's the refrigerant and water. So we've redesigned a proper real counterflow design. And also there's a lot less pressure drops, less than 30 kilopascals, which is great to reduce pressure drops in the evaporator. But primarily, it ups your heat exchange, and when you have good heat exchange, it improves the overall running costs and efficiency of the chiller. We've also, this is what I said to you, I'd explain the integrated oil separator technology. Some manufacturers use what they call cyclonic separation, where they spin the gas goes in a centrifuge effect, but as it spirals down in the centrifuge, it loses pressure, and pressure drop means, pressure drop and temperature drop means loss of energy efficiency. So Daikin have come up with an oil separator which is built into the condenser now, which is very low oil carryover and once I mentioned to you as well, very low pressure drops within the condenser, which means good efficiency. You drop the pressure, you drop the temperature. or increase the temperature depending on what refrigeration progress you're talking about. Here we can look at the current series that we offer, and here we've the inverter series, non-inverter and the inverter. So by going inverter, we also reduced the footprint within the plant room by 40%. Let's look at some application flexibilities. Okay, so here you can see there's multiple applications and advantages in operating envelopes within this chiller down to -8. You can still make ice at a -8 if you're doing ice harvesting. We can, not that it really matters for our country, but 50 or 60 hertz can plug in because we're using inverter. It doesn't matter. It's not going to affect the rotational speed of the compressor. Our power electronics determines the speed, rotational speed of the compressor. Can generate hot water for you up to 65 degrees, and we can supply up to 20-degree cold water. If you want to consider 20 degrees cold, but we can supply up to 20 degrees for data centers. We also, being data center ready, traditional units in the event of it shutting down will take around 310 seconds to restart. Because it has an induction motor in it, the current drawn by the magnetic field creates a lot of heat within the stator. So it has an anti-recycle time of at least 310 seconds, so the windings can cool down. And to get back up to full load, let's say your servers are running hot, it's going to take 20 to 25 minutes. The Daikin unit offers a rapid restart, so we restart in 15 seconds, and we're back at full load in 3 minutes. 310 seconds compared to 15 seconds, and full load up to 10 times faster than a normal chiller. And that's critical when your servers and you're carrying a lot of data and internet traffic. You don't want your servers overheating. Another good thing for data centers, we have automatic transfer switches built in, which is on a flip-flop circuit. So there's no human intervention required. The static transfer switch will engage as the generator starts up. You don't need to go there and physically do it. It's all built in for you. If you look at the switch line here, this is very noisy harmonics that you'll get in data centers because there's so many computers running. They generate a lot of harmonics. What Daikin offer is active harmonic filtration, because electrical engineer is going to be very critical of your total harmonic distortion that you're feeding back into the power circuit within the data center. So if you choose a chiller specifically, you have this as an option, active harmonic filtering, and we create a very pure sine wave. So we're not going to generate harmonics back like this and affect their power supplies and damage their computer equipment. So that's a big advantage that we offer as harmonic filtering on the inverter chiller. So we offer comprehensive solutions for data centers. Now we move on to heat pumps. If you want hot water out of our inverter chillers, up to 65-degree hot water production with optimized efficiencies. So there's no compromises between heating and cooling heat pump performance. And we perform this through this mechanical device, which monitors, you'll have pressure sensors monitoring pressure ratio differentials. They will in then turn create a voltage, which is going to drive a little solenoid, and this solenoid is going to advance or retard hydraulically the slide to optimize the compression ratio on the volume between high and low side. Quietness, also ideal for noise sensitive environments. So high performance soundproof compressor cabinets, units noise down to 81 dBs at full load, and we can go down to 66 dBs at part load. And we do that by encasing the compressor in a noise-proof insulated housing. So the Daikin choice of refrigerants for water-cooled is 134A. It's still the most efficient refrigerant for thermodynamic properties. It's classified as non-flammable, available in high quantities, and the good thing is there's no phase-out planned. So even in the Kigali ratification that South Africa signed, we're not phasing out 134A refrigerants. It's here to stay for quite a while. Mentioned to you earlier on about the new refrigerants. So the good thing is, if and when they do decide to phase out 134A, it's possible to retrofit the existing systems with lower global warming potentials, refrigerants, which we call HFOs, which are hydrofluoroolefins, and those are also going to be available at competitive prices. And this is just pretty much the inception. When we came on from 2016, we were able to reverse engineer or retrofit chillers from 2000 up to 2016 onwards with HFO refrigerants. From 2017, Daikin started making chillers with HFO. So Daikin have always been ready for any future changes. That's why we've even R32 on our air-cooled chillers. We're already there, pioneers of the environment changeovers. So now that we've looked at the chillers we offer, Daikin also offer a range of chilled water fan coil units. There are two types. We offer AC motor, which is alternating current for the simple orthodox 3-speed. We also offer digitally commutated motors. So we normally control these with a 0 to 10 control voltage, multiple fan speeds, and very low energy consumption, and a lot quieter than the 3 set speeds, and also a lot lighter on electricity than the alternating current. We also offer Chinese, what we call the Chinese range, very good fan coils, which come with a good selection of remote controllers, and they also come in digitally commutated brushless motors. So that we also offer these in the AC and digitally commutated range, fully inverter. Also on our applied side, we offer air handling units. They come with different names, a modular R, a modular P, and the professional. We also have a decentralized ventilation, so these units would probably pretty much go on the roof, and they would need ducting down through the building, ductwork. We also offer decentralized versions, which means it's a plug and play. You mount it in the ceiling, our VAM units or our modular Ls, and each floor is then independent. The advantage of this, there's a lot of redundancy. If this floor goes down, the rest of the building doesn't suffer. Here, yes, this gives you huge air volume, but if that packs up, the whole building loses ventilation. We do very large capacities, up to 750 cubic meters of air an hour. Sorry, up to the professional. We start, let me rephrase it, we start at 750 cubes, up to 144,000 on our professional range. And 500 cubes is ideal for little, possibly operating theatres where they need fresh air. It all depends on the application. All of our air handling units, especially with the COVID setup, Daikin have taken being classified with our air filter purifications to extreme measures. We have been tested by multiple organizations in Europe. If we deconstruct this air handling unit slightly, the build quality is very, very good. High efficiency filters. We have liquid gaskets, so they inject like a liquid silicone in here. When it dries, it creates very good sealing capabilities because of its flexibility. Internal rubber rounded profiles and flush inner surfaces. These are fantastic for hospital applications because they're round. When you get an induced serviceability, There's a very low risk of bacteria living in here, which is going to then feed into the operating theatres or the recovery wards. So these are a huge plus, having these quadrants and the rounded surfaces, rounded profiles for cleaning purposes. They're very, very hygienic units to use. Multiple applications these can be used in: pharmaceutical, oil and gas, hospitals, data centers, multiple ranges. And what we really focus on too is all the different filters that we can offer, and the parts per million. Each filter, your high efficiency particle accumulating filters, Daikin have gone to extreme testing and options that we offer on these different filters, and we've worked with all the top end laboratories to get certification on our filters to offer the best quality air that we can. The modular RP, slightly smaller units, comfort cooling, offices, hotels or warehouses, depending on your flow rates. And then here we offer less as important filters, but still very good at particle catchment and air purification filters, the options that we offer. And lastly, we're going to look at the connectivity. Daikin on site is a product that we are promoting. It's a very important product to have on each chiller. So what does it do? It offers pretty much monitoring from any smart device on what your plant is doing. You can access, you get web graphics, it gives you dashboards, you can remotely access it from anywhere. If an alarm goes off, you can be anywhere and have a remote diagnostic effects. Your technician on call can get an email to say that there's an issue on site. The good thing is any updates for the chiller can be done on site. Remotely. You don't need to go on site and physically upgrade. And you can schedule a whole lot of timers. It's a very good option to have for preventative maintenance, as well as making sure your chiller runs at optimal efficiency. If we spot any anomalies, like the odd let's say high discharge temperature, that's not normal, and we would, before the compressor fails, we would advise you that there's a problem, and we can do preventative maintenance. Go to site and have a look what on site. Is it something in your water pipes? Is it blocked strainers, incorrect set points? What is causing these anomalies? So all this gets remote monitored for you, all on the cloud. So here you can pretty much see you have a dashboard. You can see you can remotely go on and see your chillers running at say 30%. You can see what your set points are. If you're owner of a factory, for example, you can see what your process is doing, what important temperatures are running. If your machines are getting too hot, you melt plastics, the molds jam up and freeze. It's downtime. It's a waste of cost of raw materials. So all of this can be monitored off this very easy to read dashboard. From the dashboard, we go on to a more advanced trend, and we can see daily from Sunday, Saturday, Monday, different times, what's happening at these different trends. Why are you only getting high spikes at say 3 o'clock in the morning? We can look at monitor all of this remotely for you. So that is the advantage of DOS. Okay, thanks for attending. Has anybody possibly got any questions they'd like to ask me?